Okay, working on the homework here for 2.4. We're going to be looking at mostly here product rule and quotient rule. All right, so before I begin, I want to point out that the way I'm going to use product rule and quotient rule is a little bit different than the way the book shows it. And let me explain. If you have two functions being multiplied, so you have a product and you want to know the derivative, the formula I'm going to use is that this should be the derivative of f times g minus the derivative of g times f. I'm sorry, plus the derivative of g times f. Now the way the book does it, if the book says when you have f times g, the derivative is g times the derivative of f plus f times the derivative of g. Now they're the exact same things because we have multiplication here, so that pretty much gives us the same thing. Let me show you now the quotient rule, and I'll explain why I use the red formula instead of the blue. So with quotient rule, the formula that I will use is f prime g minus g prime f all over g squared. And the one the book uses is, let me reference this real quick because I haven't looked at this in a while. I didn't have it open to that page. I apologize. Yeah, what they use is g f prime minus f g prime all over g squared. So you can see our formulas are almost the same, except that they just reverse the order in which they do derivatives compared to mine here. And not reverse the order, they just commute the multiplication, switch the order of the multiplication. So the formulas are very similar. I really don't have a main reason why I do it the way I do it, except for the fact that that's the way I learned it. So it's like automatic for me to do it that way. So throughout here, when I'm working through these problems, just be aware of the fact that I will be using this and this, but they are the same as what's happening there in the blue. Okay, now let's move on to this first problem. First problem, find the derivative of f of x. So what we really have here is, I'll say, instead of using f here, I'm just say this is like a y. And I'm going to say this is my f function and this is my g function, and they're being multiplied. And when they say they want f prime, they really want y prime. So I want the derivative of a product. And therefore, I'll use the product rule, f prime g plus g prime f. Now, f prime is the derivative of f, which is here. And that I can do term by term. So the derivative of 1 is 0. The derivative of 9x squared is 18x. Now that's f prime. Now I need g. G, I don't do anything to it. And then I have plus, get rid of all this here. Okay, plus, now I need g prime, right? So I need derivative of this g up here. Derivative of that is, well, the derivative of x is 1, minus derivative of x squared is 2x. And now I just need to write f next to that. So f was 1 plus 9x squared. So to reiterate, this is f prime, this is g, so times g, plus this is g prime, and this is f. And now all I have to do is simplify this. All right, I actually have the derivative here, but I need to clean it up a little bit. So what I'm going to do, since that's a 0 up here, I'm going to just distribute 18x through here. So we get 18x squared minus 18x cubed. And then for these two, to multiply these two together, I actually have to expand it out. So 1 distributes through. So I have plus 1 plus 9x squared. Then distribute my negative 2x through. Negative 2x minus 18x cubed. And now I will try and collect any like terms together. And let me go highest power of x down. So let me get negative 18x cubed. And that takes care of my x cubed term. Now my x squareds. Oh, wait, hold up. Oops. I had another one back here. Missed that one. Let me fix that. So negative 18x cubed, negative 18x cubed is negative 36x cubed. So now my x cubes are gone. Okay, I've done those. X squareds, I have 18x squared plus 9x squared. That's going to give me 27x squared. And I've taken care of the x squareds. The only x term I have is minus 2x. And then the only constant I have is 1, so plus 1. So that is my derivative using the product rule. Now that takes care of the first one. It says use the product rule to find the derivative. Now it says perform multiplication first and find the derivative. So what we're going to do is we can go back up here. And let me actually multiply this out first. So if I multiply here, I get x. Multiply here, I get negative x squared. Multiply here to here, I get plus 9x cubed. And if I multiply here to here, I get minus 9x to the fourth. Now, if I look at that as being my y, and I say find the derivative, then the derivative of that would be the derivative of each of these terms. So derivative of x is 1, derivative of negative x squared is negative 2x, derivative of 9x cubed is 27x squared, and derivative of negative 9x to the fourth is negative 36x cubed, which, as you can see, matches exactly what I got here, just a different order, but it's the same expression. So you might be saying to yourself, well, wait a minute, that product rule is just way too complicated. Why not just expand everything out and then do derivative? Well, the problem is that for this problem, yes, I agree, but later on, you won't be able to expand the way you did here, and therefore you'll have to have some other way of getting the derivative, and so the product rule will be the only thing we have. All right, next one. This is a good example right here. Here, find the derivative of this. So again, I'm going to call this y, and that means I want y prime. And I'm only doing that so I can show you that if you split this right down the middle there, there's a product in there, and I can call this first thing over here f, and the second thing over here g. So in other words, my f is actually 3 square root of x, remember, is the same as x to the 1/2, and my g is actually sine x. So remember, the derivative, y prime, should be the derivative of f times g plus derivative of g times f. That's product rule, which for us is the derivative of f. We're going to look at this. We're going to use power rule, so the 1/2 comes out. We get 3/2. Subtract 1, x to the negative 1/2, times g is sine x, plus the derivative of sine x, that's the derivative of g. Derivative of sine x is cosine x, times f, which is 3x to the 1/2. And now the only thing I'm going to do is just kind of clean things up. See if you agree with this. I have 3 sine x. Those are the only two factors that are in the numerator here. All right. And I'm going to drop that x to the bottom. That x to the negative 1/2 is going to go to the bottom. It's going to join the 2 that's down there already. And remember, x to the 1/2. Once it goes down there, it's 1/2, so it'll be positive. And that's just back to this. And then I have plus the other one. Can't really do a whole lot to that. I'm just going to go 3 root x. I'll put it in front of the cosine x. And that is sufficient right there. But again, notice you could not have done what we did up here where we expanded out. Can't do that because there's no expansion possible here. So the only thing we have is the product rule. Okay, so let's differentiate this one. Notice that our variable here is y, so I can't call this side y. You can call it anything you want, really. I just leave it like that and say, what's the derivative of f with respect to y. Well, let me split this where I see a product, which is right here. I see a little f and a little g here. Now notice the f function, I'm going to rewrite it, is y to the negative 2 minus 7y to the negative 4. So I brought the y's up and put their negative exponents. My g function is just y plus 9y cubed. And now I'll need some derivatives. So you might get into a habit of just doing this where you just find the derivatives of these now and then put them all together in a second. So I know I'm going to need f prime, so I may as well get it. It's negative 2y, power comes down, subtract 1 from the power, plus 28 because the negative 7 and negative 4 multiply, subtract 1. And then on the g prime, I just get 1 plus 27y squared. So 3 came out, hit the 9, power came down by 1. So my f prime of y should be, my capital F prime of y should be f prime g plus g prime f, which is negative 2y to the negative 3 plus 28y to the negative 5 times g is y, plus 9y cubed, then plus g prime, which is 1 plus 27y squared, times f. F was y to the negative 2 minus 7y to the negative 4. Now that is what I call the raw derivative right there, but the book won't ever have that as an answer, and this software is going to want you to clean that up also. So what we have to do now is multiply these things out. So since we have multiplication here, I will have to expand like this. So let's do that multiplication. Negative 2y cubed times y. What's happening here is we have y to the first power. So when I multiply y to the negative 1, or negative 3 times y to the positive 1, I add those two exponents. Negative 3 plus 1 is negative 2. So I have negative 2 y to the negative 2. Now I do that negative 2y to the negative 3 times 9y cubed. When I add the exponents on the y's, I get negative 3 plus 3, which is 0. Y to the 0 is 1. So we're just going to multiply the numbers. Negative 2 times 9 gives me negative 18. All right, so now what we do is we move here. We do this one times the y. Add the exponents. Plus 28 y to the negative 4, because negative 5 plus 1 is negative 4. And then we have to do 28 times 9, and then add those exponents. Negative 5 plus 3 is negative 2. 28 times 9 gives us 252. So we have 252 y to the negative 2. And that's just the first one multiplied. Now we have to come over here and do this, 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 this. So let me do that there. 1 distributed through just gives me exactly what was there. So negative 2, 1 again, negative 7y to the negative 4. And then now the inside ones. When I do the 27y squared times this right here, add the exponents, we get y to the 0, which is 1. So that just gives me 27 times 1, which is 27. And then when we do 27 y squared here, we're going to have to do 27 times negative 7, which is negative 189. And then we have y squared times y to the negative 4 is y to the negative 2. All right, now let me try and see if I can figure out where my like terms are, because I'm going to start putting all this together. Here's my y to the negative 2. Here's another negative, another y to the negative 2. Here's another y to the negative 2. And here is another negative y to the negative 2. So I just need to add the numbers together. So I take negative 2. I add 252. I add 1, because that's the coefficient in front right here. Right, that's my coefficient. And then I subtract 189. And I think it's 62. So I have 62 y to the negative 2. Now let me look at my, let me get this one while I'm looking at it here. Y to the negative 4 there, negative 7 y to the negative 4. So we take 27 or 28 and we subtract 7, that's 21. So we have plus 21y to the negative 4. And now last we have our constants, negative 18 plus 27. So that should give me 9. So I have plus 9. We can box that up as our answer. Or if you wanted to, you could write that as 62 over y squared. So drop the things with negative exponents down for 21y to the 4th plus 9. I would like to check that and make sure it's okay. (62 and 21), is that right? Yep, there we go. So those are the two possible answers there. Okay, let me grab my calculator because I have a feeling I'm going to need it. Boy, I haven't worked through these homework assignments in a long time. Probably years and years. So it's kind of fun to go through these again. Okay, here we go. All right, next problem. Let me clear some of this out of here. All right, I want to differentiate what we've got here. So first thing you need to notice is that we do not have product rule here. All right, we have sine x. It's being added to something else over here. So I can do these individually, just take the derivative. So the derivative of sine of x is cosine of x, plus the 3/5 is the constant. And now you need to know what the derivative of cotangent of x is. And this is on your formula sheet, but it's also one you want to try and start to remember. It's negative cosecant squared. So negative cosecant squared x is the derivative of cotangent x. And that's being multiplied times negative 3/5. So you just go cosine x. I'll just move the negative in front and make it a subtraction. 3/5 cosecant squared x. We are done. And verify that that's the way they want you to write the answer. I wouldn't think it would have taken that much explanation. Okay, there it is right there. Okay, next one. So now we're going to get on to quotient rule. So remember the quotient rule I'm going to be using is the derivative of a quotient is f prime g minus g prime f all over g squared. So for us, what we need to recognize is we have a quotient, right? We have division, and we have a top function, which is going to be our f, and the bottom function here, which is going to be our g. So I'm going to call f that x plus 2. I'm going to call my g the x cubed plus x minus 3. I know in my formula I'm going to need derivatives of both of those, so I may as well get them now. Derivative of x plus 2 is just 1. The derivative of x cubed is 3x squared. Derivative of x is 1, and derivative of negative 3 is 0. So now it's just a matter of plugging everything into the formula. So I want f prime first, which is 1, times g, so x cubed plus x minus 3, then minus g prime, which we said was 3x squared plus 1, times f, which is x plus 2, and all of that divided by g, which was x cubed plus x minus 3, all of that squared. So I hope you can see, there is f prime, this is g, minus g prime, f, and then here's g, and then you square it. So everything there matches up. And now I'm going to try and clean this up just a little bit. So y prime is equal to, let's see, when I distribute a 1 through here, I just get the same thing. So x cubed plus x minus 3. Then I'm going to do this here, this here, this here, this here. we do that, I'm going to just do it in black up here so we can just get the answer. So it's going to be 3x cubed, then we're going to have plus 6x squared, then plus x, and then plus 2. But notice that we have a minus that's in front of that. All right? So that minus sign is going to have to distribute through to everything there, which is why down here I'm going to have negative 3x cubed, then minus 6x squared, then minus x, then minus 2, and then all of that over the denominator squared. Now I'm not going to square that. I'm just going to leave it like this, and I'm going to clean up the top. Okay, in the top, I have some like terms here, x cubed here. Here's a negative 3x cubed, so that's going to give me negative 2x cubed. Sometimes my computer just has trouble keeping up. And then now my x squared, I only have this, so minus 6x squared. And then my x terms, oh, they cancel, don't they? This x cancels with this x, so I don't have any x's. Then I have negative 3 and minus 2. It gives me negative 5. Then all over the bottom, the g squared. At this point, there's really not a whole lot more I can do, so I'm just going to leave it. Let's take a look and see the book if this came up with the same thing. They pulled a negative out. That's okay. Let's see. So they noticed all of these had negatives, so they pulled a negative out in front and turned them all to positives. That's fine. That is fine. Denominator looks good. Okay. We're ready to move on. Unfortunately, I will need to erase this because I've kind of already gotten into question 6 here. So there we go. Goodbye. All right, so here we go again. It looks again like we have a quotient because you have a numerator, you have a denominator. So if I look at it that way, let me try and use my thinner pen here. The f will be the top, which is 2t. Notice my variable here is t. And then my g will be the bottom, which is 2 plus, notice square root t is the same as t to the 1/2. I do that because I know I'm going to take a derivative now. So derivative of 2t is just 2. Derivative here, derivative 2 is 0, and then this is 1/2 t to the negative 1/2. Well, 1/2 t to the negative 1/2. I'll just leave it like that. All right, so now we are going to do quotient rule. I should point out that notice that in the original problem, they're calling the function f. And in my quotient rule, I'm calling a new function f. I don't want you to lose sight of the fact that I'm only using little f over here to help me with the formula. It's not the same f that we're given in the problem. So you got to kind of keep that in mind, that it's kind of bad notation to use f twice there. You could, if you want, come in here and use h instead, you know, but as long as you don't get lost, it's okay to just call it f over there. So my derivative will be, okay, f prime, which is 2, times g, 2 plus, I'm going to just say, well, t to the 1/2, that's fine, minus g prime, which is 1/2, t to the negative 1/2, times f, which is 2t, all over g, which is 2 plus t to the 1/2, all of that squared. All right, cleanup time. So 2 comes through. So I have 4 plus 2. I'm going to change that t to the 1/2 to square root of t. And then here, check this out. The 1/2 multiplies times a 2. That's just a 1, so it's kind of gone. And then I have this power on t, and then I have a 1 here. I add those together, I get 1/2. So I just have a minus, then just the t to the 1/2, which would be the square root of t. Then all of that over the denominator which I'm going to rewrite to t to the 1/2 as square root of t, but all of that's squared. Now on the top, notice I have 2 root t, take away 1 root t. That's just going to leave me a root t. So I have 4, I'm going to have plus 1 root t up there over 2 plus root t squared. Now be careful, you cannot just square each one of those, right? If you wanted to square this, you have to square the whole thing, which means you have to FOIL it. We can't start canceling crazy math like this and doing that. You can't do that. So we are pretty much at our answer at this point. Let's verify it. Wonder how much work they show. They probably show all the steps. Yeah, pretty close. So here we were, right there. Okay, next one. Actually, yeah, is this the last one, this page? Let me finish this one, I'm gonna take a break. All right, so I have division. I'm gonna call the top one F. That'll be 6x. Call the bottom one G. 7 minus cotangent x. The derivative of f is just 6. The derivative of g, well, derivative of 7 is 0, so don't worry about that. Derivative, forget the negatives there for a second. Derivative of cotangent x is negative cosecant squared x, but then I have a negative, so it just becomes positive cosecant squared x. All right, now we're ready to use our quotient rule. So quotient rule tells me that my derivative will be f prime times g minus g prime times f, which is 6x. And just remember that the x here is trapped inside the cosecant function. You can't multiply that x times 6x and get 6x squared. That's a big no-no. Okay, all over bottom squared. I mean, sorry, g squared. So 7 minus cotangent x and then squared. And I'll do a little cleanup here. I'll just distribute through here like that. So we've got 42 minus 6 cotangent x. And then here, you can't really do anything to this. So we're just going to have a negative 6. I'll put the constant out front. And cosecant squared x. Oh, 6x. Oops, forgot the x. Cosecant times cosecant squared x all over 7 minus cotangent x squared. Now, they put this as the answer, which is fine. All they did was they took this answer and they pulled a 6 out of everything and factored it out. No big deal. Same thing. So we're done. Break time for me. Back to work. I knew that was going to happen. My dog is at the door scratching away. I should say my wife's dog. Okay, quotient rule. If this dog gets out of control, I might have to pause the video again. I'm sorry. Although it probably doesn't make much of a difference to you, huh? Just cuts in and comes right back, huh? All right, so we have quotient. Call the top, right, f. That's going to be x. The bottom, now check out the bottom. Be careful here. I have x plus. A is a constant, so here's my constant. Now I'm supposed to put it over x, but I know that to use the power rule, I need to bring that x up. So I'm going to write it as an x to the negative 1. That's a very, very important part of this problem. Now let me grab my derivatives real quick. 1. Now be careful here. The negative 1 comes out, makes it a negative a. I subtract 1, x to the negative 2. All right. So the derivative should be the derivative of f, which is 1, times g, which is 1 minus a. Oh, no, that's not it. I almost put g prime there. Times g. Okay, and then minus the derivative of g. I forgot to put my g prime mark there, that's why. Is 1 minus a x to negative 2, and then times f, which is x, all over the g, which is x plus ax to the negative 1 squared. Ooh, this is ugly. Okay, distribute a 1 through here. That's great. Nothing changes. So I have x plus ax to the negative 1. Then distribute just an x through here and here. So, and notice also we have a negative sign. So whatever I do when I multiply this times this, I get x, but then I'm subtract it, so that gives me negative x. And then when I multiply the x times this one, right, it gives me a negative a, but then I add the exponents. This x has a 1 on it. Negative 2 plus 1 is negative 1. So I would have negative a, x to the negative 1, but then the minus out front makes it a plus a. So I have plus a x to the negative 1 all over the bottom, x plus ax to the negative 1, all of that squared. Now, oh wow, those x's cancel. Isn't life great? Okay, and now these are exactly the same. We're adding them, so there's 2 of them. So I have 2a x to the negative 1 over x plus a x to the negative 1 squared. Now, you could write this as 2a over x over, so all I did there was I rewrote this right here. I dropped that down below the 2a. The denominator I could rewrite as x plus a over x squared. And again, all I did there was rewrote the x to the negative 1 underneath the a. Curious to see what they have. Y'all can probably hear that ridiculous animal, right? Oh, they went even further. Okay, well, I'm going to have to do a little more work then if I'm going to make it look like the back of the book, or back of the book, the solutions here. All right, good. This will be a good exercise. Okay, so at this point, I'm going to give myself a little room. I'm going to work it up here. Now, technically, on your handwritten test, on your midterm and final, I would be happy at this point, okay, where I am here. But if we want to make this look like the book, then let's work with a little more. And this is just a good exercise with algebra, you know. Notice on the denominator that if I wanted to put these 2 terms together, I need a common denominator, which means I need to rewrite x over 1 with an x on the bottom. So I multiply x on top and bottom right here. When I do that, I would get x squared over x, and then the other one would be plus a over x. So I can put the 2 numerators together like this, and then I would have squared. So hopefully you agree with that. And now what I could do is I could write 2a over x over x squared plus a squared over x squared. So all I'm doing now is I'm actually squaring the top and the bottom separately. And then here's the tricky part. Because I have an x down here in denominator, I have an x squared down here in denominator, what I can do is I can multiply by x squared on top and bottom. It's like multiplying by a 1. What happens down the bottom is this x squared cancels out with this x squared. And then one of these x's cancels out with one of those x's. So I'm still left with an x up here on the top, which combines with my 2a to give me 2ax. And then over, the only thing left on the bottom is the x squared plus a squared. And that, I believe, is what they had. Let's see. There it is, 2ax over x squared plus a quantity squared. That's it. Another way, just so you can see it, that you could have done this step, might be a little bit easier for you to see, is to remember that complex fractions, division of fractions, same as multiplication of the reciprocal. So if I take the bottom and I flip it and I bring it up here, like this, that now it's gone because I flipped it up. Then this x squared becomes an x, and this x is gone, cancels. So you still get the 2ax over that bottom part. So either way, you get the same result. All right, so now we are going to go back to what we've done before, finding the equation of tangent lines to some curve at a point. To find the equation of tangent line, we actually need to come up with a slope. The slope's going to come from the derivative. So first I need the derivative. So let's see if I can work a little bit faster here. Let's see if I can do this mentally. So here's my f, and here's my g. The derivative should be f prime, which is derivative of the top, times g, the bottom, minus the derivative of g, which is the bottom. Derivative of bottom is 2x plus 1, times the top, which is x squared minus 1, all over the bottom, x squared plus x plus 1 squared. Holy crap, that is the slope of the tangent line at some given point. Now we could try and clean this up. In fact, they do that here. They clean this all up and they get something. But really, if I want to know what's happening, what the slope tangent line is at this point, then I really want to know what happens when x is 1. So what I'm going to say is that the slope, right, the slope is going to be equal to, now I'm saying the slope at that point when x is 1, just plug 1 in for all your x's. So 2 times 1 here, give me 2. And let's see, 1 squared is 1, plus 1 plus 1. So we get 3 there, so that's a 3. Minus, let's see, 2 times 1 here is 2, plus 1 is 3, so I have 3. And then over here we get 1 squared, which is 1, minus 1. Hey, 1 minus 1 is 0, so that's going to kill that 1 off. On the bottom, 1 squared is 1, plus 1 plus 1, I have 3, but 3 squared is 9. So what I get here is 6 over 9, which is the same as 2/3. So at that point, my slope is 2/3. And of course, once we know the slope, then we plug into our formula, which is this one, y minus y1 equals m times x minus x1 right there. So this is it. And then you can solve for y, which we've done that before, and you get this. All right. I'm like halfway through this assignment. Crazy. All right, find the equation of tangent line of this curve at a point. So here's this curve called the witch of Maria Agnesi. And this is actually the curve. This is the one that they're talking about. So, well, I'm saying it looks like that. We have to pick which one of these they're talking about. But to find, again, the equation of tangent line, we need the slope, right? The slope's going to come from the derivative. So first let me rewrite the function just so you can tell what it is. It's division because it's 1 over 1 plus x squared. That's what that is up there. Now let's talk about derivative. Now we have a top, we have a bottom. We use the quotient rule. The derivative of the top is 0, right? Derivative of 1 is 0 times the bottom. That's really not going to matter because 0 is going to kill it. Minus the derivative of the bottom. Derivative of the bottom is just 2x times the top, which is 1, and then over the bottom squared. Let's get rid of this whole thing because the 0 is going to kill that out. I'm left with negative 2x over 1 plus x squared squared. Now what we're interested in is what's happening when x is negative 1, and that'll give me my slope. So my slope, right, again, with x being negative 1, so I'm going into this and I'm plugging in x is negative 1, I get negative 2 times negative 1 over 1 plus, be careful here, negative 1 squared squared. So the numerator gives me 2. The denominator, negative 1 squared here is 1. 1 plus 1 is 2, but 2 squared is 4. So we get 4. Here we got 1/2. And so the slope of my tangent line is 1/2. Now we can come up with the equation. I'll just throw it in here. It'll be y minus, what was y0 here? Y0 up here was 1/2, equals m, which we just found to be 1/2, and then times x minus x, did I say y0? I meant this formula. I meant to say y1, and then this, sorry, this was x1 up here. This one was right there, x1. And then we have, let's see, x minus whatever this one was. So minus a negative, double negative means plus. Distribute through. Y minus 1/2 equals 1/2 x plus 1/2. Add 1/2 to both sides. 1/2 x. When you add a 1/2 and a 1/2 together, you get 1. So you can see right here we match up. We got the equation. But which of these is it? Well, it's pretty simple. You just have to figure out which of these tangent lines, right, corresponds to this. So which one of these has, let's see, a y-intercept of 1? This one does. That one does. That one does. Which one has a slope of 1/2? Well, this one right here. You can even tell by the point. Negative 1/2, 1/2. None of the other ones. Well, they all had them, but the tangent line wasn't there, so it's going to be this one right here. Ooh, finding double prime of this one. Oh. Well, shall I work this or just point out the solution here for you? Let me see how this works. Remember their formula is going to be a little different. They go GF prime minus FG prime over G squared, which is down here. So this is still F, this is still G. So we have G here. Now the derivative of F minus F, and then the derivative of G, then all over the bottom, which is G squared. Then they do some algebra, they distribute 2x through, multiply those together, they get this. And then, let's see, put those two together, and you put them in descending order, and you get this. This is our derivative. They also square this out. So they actually take the denominator, 1 plus x times 1 plus x, and they multiply that out. And that gives you the bottom right here. Okay? Then, because they want the second derivative, they want the second derivative at 1, you have to take derivative again. So now it's like you're starting a whole new, brand new problem. Here's your f, here's your g, and then go through the same whole process again. Now, because I've done, I think, a good, fair amount of these, hopefully you can see the second derivative here is just quotient rule on this, and that's all worked out here. They simplify it out, and they get this right here. So take your time through that, okay? It is a little bit tricky, but if you just take your time, things will work out. Notice that you do get this x plus 1 here, and the x plus 1 to the 4th. One of these cancels, and that's why you get cubed here. And then what they do after they do all that is they plug in 1, and when they plug 1 in for x, they get 1/4. All right, taking a look at number 12. If f is secant x, then what is the second derivative at pi over 4? So first of all, you have to know what the derivative of secant is. Secant x. Derivative of secant x is secant x tangent x. And now if you want to do the second derivative, you have to take derivative of that, which is a product, because you have two things. Now again, I'm going to call it f, even though it's kind of weird to call it f because this is already the derivative of f, but this is just so we can see the product rule. Right, so product rule says f prime g plus g prime f. So first I take derivative of f. Derivative of f is secant, it's secant x tangent x again, times g. G was tangent x, so I have another tangent x there. Plus g prime, derivative tangent of x, is secant squared x times f, but f was secant x. So you get secant x tangent squared x plus secant cubed x. And there's probably some trig identity in here that we could grab out. Let's see if they go that far. Oh, no, because they just want us to plug in pi over 4. But I still want to see how far they went with the derivative. Did they? Yeah. No, they just pulled the secant to x out. They just pulled one secant out. We don't need to do that. Okay, so let's figure out what secant of pi over, or what f double prime pi over 4 is. Remember, if this helps you, if I want to plug pi over 4 into this, so f double prime pi over 4, then what I need to do is rewrite secant. Secant is 1 over cosine, and then what I would do is plug in pi over 4. That pen's too big. Then tangent here, right? Tangent is sine over cosine, so sine of pi over 4 over cosine of pi over 4. You don't have to go all the way down to sine and cosine, but it might help you. And then all of that's being squared. Then plus, let's see, all this being cubed, secant we said was 1 over cosine, so cosine pi over 4. All right, cosine of pi over 4 is the x-coordinate on the unit circle at pi over 4. So we should get root 2 over 2, but 1 over root 2 over 2, 1 over root 2 over 2 should be 2 over root 2 times, now again, you know, I really don't like this. I should have just stuck with tangent here. Tangent of pi over 4, instead of this, tangent pi over 4 is 1, and 1 squared is 1, so that just gives you 1. And plus, we just said right here that 1 over cosine of pi over 4, that's going to give you 2 over root 2, but then you're going to cube that. So here's where we are. We have 2 over root 2, plus if I cube this, I get 8 2 root 2. And that's because if I take root 2 times root 2 times root 2, the first 2 give me a 2. That's this right there. And then I have that root 2. I'll get a common denominator real quick. Multiply top here and bottom by 2. So I get 4 on top plus 8, that's 12 over 2, common denominator 2 root 2, and then that's 6 over root 2. Geez, they probably rationalize this too. So they probably multiply now root 2 on top and bottom, which will give me a 6 root 2 over, let's see, root 2 times root 2 is 2, and that's just going to be, my goodness, 3 root 2. All right, let's see if we got it. Yay, 3 root 2. So, boy, they didn't show you a whole lot there. I guess they just kind of assumed you could get all that. Not surprising. All right. I think I need a break. Okay, for number 13, I want to point out, first of all, our variable is theta, not x, not y. It's theta. Now, that's fine. We just got to treat it like we've treated x the whole time. Notice we're trying to find the derivative and the second derivative of h, and we have theta times cosine theta. So we actually do have a product right there. So let's try our h prime. Remember, this is like our f, and this is like our g. So we're going to go f prime. The derivative of theta is like saying derivative of x. That's 1 times g, cosine theta, plus, because product rule, derivative of g, which would be, derivative of cosine is negative sine theta, then times f, which is theta. And now, clean this up a little bit. We have a cosine theta out front. And then this theta, I'm going to slide it in front and make that a subtraction, so minus theta sine theta. And now what we want to do is we want to take derivative of this. So notice we have two terms, right? And then in one of those terms, we have a product. So the way we'll do this is we first take the derivative of the first term there. Derivative cosine theta is just negative sine theta, and we are done with that. Then minus, now this is very important, minus what? Well, minus whatever comes out of the product rule. So we need to keep track of that minus sign right here, do our product rule on this, and then distribute that minus sign through. So it's kind of like a brand new problem. We've got our f here, we've got multiplication, we've got our g here. Derivative of f would be 1. Derivative of g would be cosine theta, plus derivative of g, which is derivative of sine. Oh, I can't believe I just said that. Derivative of f, which is theta, times g, which is sine theta. My goodness, I must be tired. Then g prime, which is cosine theta, times f, which is just theta. Now I will distribute that negative sign through. We have the negative sine theta out front. Now this negative multiplies through here, and we just get a negative sine theta again. And then that negative comes through here and hits this. Now that theta right here, I'm going to slide that out in front, and it becomes a minus theta cosine theta. And finally, these two are exactly the same, negative sine theta and negative sine theta. Put those together, you get negative 2 sine theta. And then you have that minus theta cosine theta, and that's right here. So you could leave it in that order. I mean, you could have. Wouldn't be wrong to write it this way. But you could write it the way they have it also. Okay, moving along, moving along. Okay, this one they want you to fill in the blanks, I think. So let's start this thing out. We want the derivative of cosecant. Or actually, we want to show that this is true. Prove that identity. So now, what we first do is we rewrite cosecant as 1 over sine of x. So we want to know what the derivative with respect to x is of 1 over sine x. Now we're going to use quotient rule. Here's f, here's g. Right? We have a numerator, we have a denominator, quotient rule. But because they're doing this solution, they're going to use their formula. So they're going to go gf prime minus f g prime over g squared. So we want to put g first, sine x, then f prime, there's f prime, derivative of the top, and then here's f, right? There's f prime, this was g right there, and now they want us to put g prime. So what's derivative of g? Well, what's derivative of sine? It's cosine. And then they have the bottom squared. And then on top, we know that this goes away. And all we're left with is a minus 1 times cosine theta, which is minus cosine theta, or theta x. And then what they do, it's kind of hard to see this, but what they do is they take the negative cosine x over, you could look at it this way. They just kind of split everything apart like that. So they take the negative cosine x on top, and then they take the sine and split it into 2. And then notice that if you were to put those two back together, you would get, if you were to look at the negative, slide it out to this one, it wouldn't be there. And then you would have this and this. Cosine over sine. And we know by definition cosine over sine is cotangent, so there's cotangent. And then this was your negative 1 over sine, but 1 over sine is cosecant. So there you go. Am I almost there? All right, suppose that f of 5 is 1, the derivative of 5 is 2, g of 5 is negative 6, and g prime of 5 is 9. Find the following values. They want to know what the derivative of the product is at 5. All right, well, I know that if I have f, g, and I want to take the derivative at, let's say, some value x, the product rule says this would be f prime at x times g at some value, and product rule, so plus the derivative of g at some value times f. But we want to know what's happening at 5, so we just replace this with 5, 5, 5, 5, 5. So the product derivative of the product at 5 would be f prime of 5 times g of 5 plus g prime of 5 times f of 5. And they gave us all those values. So f prime of 5, let's see, where's that? F prime of 5, that was 2 times g of 5. G of 5 is negative 6 plus g prime of 5, which was 9, times f of 5, which was 1. So negative 12 plus 9, what do we get? Negative 3? Yay. They used the other, oh, we got to do all these? Geez, I'm going to open that up. I don't feel like doing all this. Okay. So they got negative 3, there it is. Now, if you want to do the quotient, then you set up the quotient, and then you plug in all the values again, and then you get that. And if you do the other quotient, g over f, then the quotient rule changes a little bit, and you plug in your values and you get this. Boy, I hope that makes sense. Same thing I just did here, except that on this one you do quotient rule, and then this one you do quotient rule the other way, so the g and f switch places, and then you plug in all your values. This one's the same thing, but they want you to do it all graphically. It's a little confusing. Okay, so they want to know what u prime of 1 is, but u is f times g. So u prime would be equal to the derivative of a product, so it would be f prime g plus g prime f. And they want to know what's happening at 1. So first, let me look at this. What would be the derivative of f at 1? So here's your f function. If I go to 1 on the x values, so that would be here, I go up to the function, and I want to know what the derivative is, right? What the derivative is at that point, right? Come on, erase. Oh, no. Oh, no. I wanted to know what the derivative of f was at that value 1. That means the slope of the tangent line. So I need to find the slope of this line. Slope of this line is rise over run. So 1, 2, 3, 4, rise, 1, 2, run. So that has a slope of 4 over 2, which is 2. So that's just 2. Now times, now what we need to know is what's happening to the g function, but not the derivative, the g function itself. So this is g. So I want to go out to 1 again. And I want to go to the g function, which is right here. And I want to know go out to 1, go to the g function, which is right here. And I want to know its value there, not the slope of the tangent line. And the value of it, come over here on the y-axis, is 1. So that's a 1. Then plus, now we're going to look at g again. Right, here's g. This time, I want to know the derivative's value there. So I will go out to 1 again. So 1, I go to g, there it is. Now I need to know the slope of this tangent line. And I can just pick, any 2 points here and go, let's see, down 2 over 2. 2 over 2 is 1. So the slope, negative 1, down 2. So this should be negative 1. Slope is negative 1. Now I need to know what the function f's value is at 1, not the derivative, but its value. So I go out to 1, go up to f. I find its value. The value of the function there, it looks like it's 2. So I plug in a 2 here. Crap, all that for nothing, right? And you can see that's what they get right there. Okay, now just keep in mind that the reason why I was using 1, that I kept on going out to 1 here, was because they were looking at u prime of 1. Now what we want to know is what's v prime of 5. So everything we're going to look at is going to be at the 5 on the x-axis, but we're also looking at v. V is this function, which is a quotient. So the derivative of v would be quotient rule. I'll do it my way. It'd be f prime g minus g prime f all over g squared. So let's start with looking at the f function, and we're going to look at f prime. So here's f function, and we are going to look at going out 5, 1, 2, 3, 4, 5. Go up to the function and find the slope of that tangent line. Well, the slope of that tangent line is actually the slope of this line. I just need to be able to figure out that slope. That looks like a point, and the point that right here was a point. So it looks like if I go down 1 and over 1, 2, 3, so down 1 to the right 3 means that that top right piece should be negative 1/3. And now what I need is g, but I don't need its derivative at 5. I need its value at 5. So I go out to 5. I go to the g function, which is the blue one. I find its value there. The value there is 2. So this top left finish up, that's a 2 minus. Now I look at the g function, and I look at its derivative at that value. So I'm back here at that point. I want to know the slope of the tangent line here. Let's see, well, that's a good point on there. Let me see if I can get to another good point I know of. Looks like right there is a point. So rise is 1, 2, run is 1, 2, 3, so 2 over 3, 2/3. And now I can look at the f function, and I'm looking at its value at 5, not its slope. So let's go out 5, 1, 2, 3, 4, 5, go up to the f function, come over here, figure out how high it is. That looks like a 3. And so this should be 3. All over g squared. G squared. Well, we already know what g is, right? Right here. We already know what g is at 5. All we're going to do is square that. So we take that 2, right? That was what it was, and we square it. All right, so what do we get? Negative 2/3, and then minus, let's see, these 3's cancel, minus 2 over 4. Get a common denominator here, so put 3 here, multiply 3 on top. So I get negative 2, take away 6 over 3. Do it right here. Negative 2, take away 6 over 3, but then all of that is over 4. I'm going to look at that as 4 over 1. We get negative 8. Negative 8 over 3 over 4 over 1, and then do your multiplication of the reciprocal. Scratch that out. 8 becomes a 2, that becomes a 1. Let's get negative 2/3. That's it right there. All right, I think I'm getting pretty darn close. Last one. Yay, I'm excited. I really am. This seems like it's really been a long assignment. How long is this video? Oh my god, this video is an hour long. Jeez. Okay, how many tangent lines to the curve y equals x over x plus 1 pass through 1, 2? All right, I'm going to talk you through this one, because a lot of this is just understanding what they're asking and not necessarily the doing it. How many tangent lines to this curve pass through this point? So you've got some curve sitting here. Well, let's start with the point. You have a point. 1, 2, right there. Then you got some curve, and I'm just going to give you an example of a curve first to give you just an idea of what this is asking. Let's say we have a curve that does something like that. Okay. And I ask you, how many tangent lines to this curve pass through that point? Well, looks like if I take the tangent line here, it looks like that tangent line does pass through that point. But that's not the only place. Looks like there's another point over here where that tangent line passes through that point. So for this particular curve, it looks like there's 2 tangent lines that pass through that point. They want to know for this function how many lines pass through that point without you looking at the graph at all. All right, so think about what they're asking. Let's start with this. I'm going to come down here and try and explain through this. Okay, if this is your function, then the derivative is this. So you could go and do quotient rule and clean it all up, and you would get this. That means that whenever x is some value a, we would know the slope of the tangent line. This would be the slope. We just replace this with a. So the general equation of a tangent line would be y minus, this is actually y minus y1 equals m times x minus x1. That's what we have in this formula here. You know what? I think I'm going to write this down up here. y minus y1 equals m times x minus x1. So m here is this, and that came from this right here, the derivative, plugging in a for x. And then the x minus x1, right here, x minus x1, but the fact that this is an a comes from the fact that we're wanting to know, we had let x be a, right? We had let x be a, and so that's where we are on the x-axis. Our x-coordinate is a. And then this piece, this is the part that's a little tricky. This y1 right here is this. Now, why is that true? Well, remember, the original function here, right, the original function says y equals this. Well, if I go in here and I replace this x with a, this x with a, then I get a over a plus 1. So this is really what y is equal to. Sorry, circled the wrong y. This is really what y is equal to when I replace my x's with a. So that's the y-coordinate when the x-coordinate is a. Okay, hope that all made sense. It's a tricky problem. So here's where we are. We have this equation. This is what the equation of a tangent line looks like. Now this line has to pass through the point 1, 2, right? We want it to go through some point. So that means I can replace x here with 1. I can replace y here with 2. So notice that y right there becomes this 2. Everything else is the same. And then that x right there becomes this 1. And then what you have is an equation that has just a in it. So what you do is you start putting things together. You would get multiply both sides by an LCD, which would give you this. And then you expand things out, and you get this. And then keep simplifying, and you get a quadratic equation. Use a quadratic formula. When you do the quadratic formula, you get these two solutions. And so that tells you that there are two tangent lines that actually do that. And to figure out what they, does it ask for it? There are two. At which points do they touch the curve? So all you have to do is take these points right here. There's two of them, right? -2 plus root 3, -2 minus root 3. Plug them into the function, and it would give you two different answers right here. So this is the picture. So you have a point sitting here in space. Here's the graph. Here's the actual graph of this curve. It goes like this, and it goes like this. And what we found was that there are 2 points where if you look at the slope, or if you look at the tangent lines, they cross through that point. This is a somewhat advanced problem. I probably would not ask you this on a midterm or on a final, but it is a good kind of put all the ideas together and, use quadratic formula. Lots of cool things in here. So I think I'm done. I'm very happy.